In any distributed system, individual components will eventually fail. Servers crash, networks drop packets, disks die. In this video, we look at how well-designed architectures anticipate that reality and keep working anyway, using fault tolerance and redundancy as their core tools. Imagine you have a web application that talks to exactly one database server. The moment that server goes down, for any reason, a bad deployment, a hardware fault, a full disk, your entire application stops working. Every user sees an error. And as systems grow and add more components, the probability that something is broken at any given moment actually increases. This is the core pressure fault tolerance is designed to relieve. You do not wait until you have a flat tire to buy a spare. You carry one in the boot before the trip. Fault tolerance works exactly the same way. You provision backup capacity before a failure occurs, so when a component does fail, the backup is already in place and the system can switch over without the user noticing a thing. Here is what a fault-tolerant architecture looks like structurally. A load balancer sits in front of two identical application servers. If app server A goes down, the load balancer stops sending traffic to it and routes everything to app server B instead. The database tier mirrors this pattern. A primary database replicates its data to a replica, so if the primary fails, the replica can be promoted. Every critical component has at least one counterpart, no single point of failure. Let us trace a request through a failure scenario. The client sends a request. The load balancer forwards it to app server A. App server A does not respond within the allowed timeout. It has crashed. The load balancer notices this through a regular health check, marks app server A as unhealthy, and automatically reroutes the request to app server B. App server B processes it normally, and the client gets its response, likely with only a small delay. The key consequence is that the client never needed to know a failure occurred. Fault tolerance is not free. Running two application servers instead of one doubles that part of your infrastructure bill. Keeping a database replica in sync adds replication lag and consistency concerns you have to reason about. Failover logic is extra code that can itself have bugs. The decision comes down to one question. What does downtime actually cost you? For a payment processor or a hospital system, the answer is enormous. For an internal admin tool used by 3 people, the answer may be almost nothing. Start by mapping your system and asking, if this one component disappeared right now, what breaks? That component is a single point of failure and a candidate for redundancy. Beyond duplication, use retries for brief transient errors, but add a circuit breaker so you do not flood a struggling service with requests. Graceful degradation is especially powerful. Instead of showing an error page when a recommendation service fails, show the page without recommendations. Keep the core working even when the edges are broken. The central insight is that failure is not an edge case. It is a certainty at scale. Fault-tolerant architectures accept that premise and design around it from the start. Redundancy removes single points of failure, automatic failover handles the switchover, and graceful degradation ensures that a partial failure never becomes a total one. The result is a system that earns user trust precisely because it keeps running when things go wrong.